This is the second in a series of videos in which I'm developing a logic comparator. I showed in the previous video the basic way that this unit will work, and in essence what you do is you provide the unit with a reference IC that's the same type as the one that you want to test on the unit you're repairing. And what the device then does is it compares the performance of the reference, which in theory is a known good device, with the unit on the board that you're trying to repair. And if the two don't match, then on a pin for pin basis it will give an indication through an LED of a discrepancy between the reference IC and the one that's on your unit under test board. The design is based loosely on the HP logic comparator. You sometimes see them popping up on eBay, but they usually go for very high prices, sometimes as much as £1,000, and that's way too expensive for what they are. And in addition, they tend to only support up to 18-pin devices, and quite often when I'm repairing equipment I need to be able to test 40-pin devices. Moreover, they might be fairly unusual devices, so 6522s, 6521s, microprocessors, shift registers, DRAMs, all this sort of thing that's very dynamic. And this is where really standard testers can't really help that much. Firstly, you have to remove the IC from the board to use them, but also the chances of you having a suitable test unit for all the different devices you'll come across is fairly remote. So that's why I decided to design my own. The biggest issue in designing something like this is the physical implementation of it. The circuits are fairly straightforward, but I'm sure you've all come across devices that in theory sound quite nice, but when you try to actually use them they're hopeless and they become things to avoid at all costs. And I don't want that for this device, firstly because I want to use it myself, but secondly because I want it to be something that will be useful to other people. Having said that, anything that has to address 40 pins in real time at high speed and needs to be able to handle pretty much unlimited and unknown IC types is always going to be a bit of a challenge. But I've got as far as designing the schematics. This is on the second day, so it hasn't taken quite as long as I expected to get the schematics done. The first problem I encountered, however, was when I started doing the board layout, and because of the number of pins this unit will support, I ended up with a very large, very complex board. This is not it. It was twice as big as this, and I realised that it was going to be fairly impractical. It was going to give a very large footprint device. Now, although the test clip is on a lead, so you're not having to sort of bring this over to your unit under test, it's still not ideal to have a very large unit on the bench when you're trying to repair equipment. So what I ended up doing is rethinking the way the layout was going to work. I want to have up to 40 pin support for this device, but it also occurred to me that maybe not everyone wants that. They're not going to want to build a huge board that will support 40 pins if they're only ever going to use it to test 14-pin logic devices. So I had a bit of a rethink, and what I've ended up doing is I'm going to configure it so it will use two of the comparator boards. These boards will be identical and they'll be stackable, so if you want you can build just one for the unit and that will support up to 20 pins, and if you want to put if you want to add a second board, then all you do is you build a second board and that will connect onto stackable connectors on the bottom of the first board, and it's up to you if you have one board or two boards. Just bear in mind, if you only have one board, your device will only support up to 20 pin ICs. So they'll be stacked on stackable connectors, and then on top of this there'll be a third board which will be the display board. So similar kind of layout in that respect to the HP. So down the side of a cutout will be a row of LEDs, 20 down each side, and obviously when you have a unit in for testing, if it's a 40 pin then all 40 LEDs will be in use, or if it's a smaller device it will be fitted at the top and then just the top LEDs will come into play. As with the HP, the way these will be fitted to the unit under test, if I remove the bottom two boards and we have the display board, and the devices will be put onto small module boards. So you can put a socket on here if you want to, so you can reuse these. And then there'll be a series of shortable links, so you'll be able to configure the particular device. What you have to do is tell the unit which pins on a particular device are inputs and which are outputs. And that's what the links will do. You will just short the links out that are inputs, and they'll be fed straight through to the comparators in the unit. This will then slide into an edge connector, so you push this into the top of the device. It will engage with an edge connector underneath this top display board. So when you've got the thing plugged in, it will just look like this, where you have the device, this is your reference device of course, and poking through this slot, and then it will line the pins up with the LEDs. And if you have a smaller device, of course, it will just sit at the top of the slot. This will give you maximum flexibility, and you'll just have one or more of these module boards. You can reuse them as long as the pinouts for the various devices are the same, but otherwise you will need to configure them for each particular device that you want to be able to test. I did consider putting rows of DIL switches onto this module to make it reconfigurable, but I realised that that would actually be far more expensive in terms of switches than just buying another board, so it kind of defeated the whole point. So this format gives me quite a nice small footprint. The unit will be this kind of size. It might vary slightly when I start doing the final layout. You'll be able to configure it as a 20-pin test unit or as a 40-pin test unit, and then I'll make these boards as cheap as I can. I'm going for just edge connector style connections, and the ultimate size of this is going to really depend on the edge connector I can find that best suits this application. Obviously this will need at least 82 connections, double-sided of course, so it'll be 41 pins wide at least, and that's what's going to dictate the width of this board, and that in turn is what's going to dictate the width of the rest of the test device. So that's as far as I've got at the moment. Any comments on what I have planned would be welcome. As I say, the whole point is to make this as usable as possible. I want it to run up to the full speed that most of the boards we'll be testing will operate at, and I want to make it practical. So as I say, any comments welcome, and I'm aiming to try and get this available within the next 5 or 6 weeks.